Hello, my name is Carmen Lamothe, and this is my unit project 2, exploring protein form and function through modeling. My assigned protein was the Piezo 1 protein, and my assigned mutation was arginine 2456 is replaced by histidine R2456H. The normal function of the Piezo 1 protein is that it is a pore-forming channel that mediates mechanotransduction in mammalian cells, indicating that Piezo 1 plays an important role in maintaining erythrocyte volume homeostasis. Piezo 1 channels are homeometric 3-blade propeller-shaped structures that utilize a cap motion and plug-and-latch mechanism to gate their ion-conducting pathway, which I will show in my 3D model later on. Those 3 blades all surround a central domain, which is composed of 1 C-terminal, 1 cap, 3 inner helices, 3 outer helices, and 3 anchors and latches. They are essential in regulating many physiological processes. This protein is normally found in the endoplasmic reticulum membrane, only in eukaryotic cells. Typically, the Piezo 1 protein is found in non-sensory tissues such as endothelial cells, red blood cells, bladder, kidney, and lung cells. If I were to categorize the type of change the mutation has on the protein function, I would choose the protein becomes more active because when arginine is replaced by histidine, the histidine slows the inactivation function in the Piezo 1 function, making it more active. This mutation alters mechanosensitive channel regulation, leading to increased cation transport in red blood cells. Although I chose the protein becomes more active, it could also be defined as a gain of function, as it prolongs channel activity in response to a given mechanical stimulus. So, here is my 3D dimensional model. I chose to use pipe cleaners to represent the amino acid side chains and the 3 blades. Represented by the yellow pipe cleaners is the cap, and the colors represent the anchor and latches amino side chains that cover the cap. To represent arginine and to see it clearly, I have this pipe cleaner. The main functional groups in the original amino acid side chain are an amino group and a carboxyl group. The properties of the original amino acid side chain is that it is hydrophilic, it is positively charged, and compared to the 19 other standard amino acids, I would characterize it as large because it is approximately 2,500 amino acids long. So, due to its polarity, arginine can form hydrogen bonds with polar groups to contribute to the 3D folding of the protein. That is one of the types of interactions that the original amino acid can participate in. However, when mutated, when arginine is replaced by histidine, the main functional groups do stay the same, an amino group and a carboxyl group. It is hydrophilic still, but it has a hydrophobic gate in the inner pore helix of the channels at some stages. Differently from the original amino acid side chain, it can be positively or negatively charged depending on the overall pH. And compared to the other 19 standard amino acids, I would still characterize it as large. The difference in the types of interactions that the mutated amino acid side chains can participate in compared to the original amino acid is that the mutated side chain can form hydrogen bonds and ionic bonds because, as I said before, arginine is positively charged, but histidine, however, can be positively or negatively charged depending on the overall pH. And again, this assigned mutation alters mechanosensitive channel regulation, leading to increased cation transport in red blood cells. As I said before, it can be defined as a gain of function as it prolongs channel activity in response to a given mechanical stimulus. Mutations like arginine replacing histidine are associated with certain diseases like dehydrated hereditary stomatocytosis, a condition causing red blood cell dehydration due to abnormal ion transport. Lastly, the limitations of my model include that 1, it is not detailed enough and does not show exactly how the cap looks and every single amino acid chain that could be included. And my arginine and histidine are obviously not to scale or in the right place, but I wanted to show them clearly and how the mutation occurs and that it is replaced. Thank you.